In this video, we are going to convert between degrees and what is called degrees, minutes, seconds. Okay, so what degrees, minutes, seconds is, I'm going to use a little space up here from the last section, is that if we take our normal circle, let me make a straight line here, it's my Cartesian plane, and we think about, that's not straight, hold on, there we go. Okay, and we think about our degrees. Let me draw a circle in here for something rotating through. Usually it corrects right away. There we go. Okay, so I have my circle, and I'm thinking degrees, minutes, seconds. So what that is if we look here, we actually have, like, this could be like, let's say 30 degrees, and we have a rotation going around, and we have like, okay, this isn't going to be to scale, but let's say it's 29 degrees, right, going in between. So 29 and 30 degrees, degrees, minutes, seconds. We have degrees, but we can actually break this down even further. Like, we could, instead of using like 29.8, 29.9, stuff like that, we could break it up, and each one we can break up our minutes. What we do is we take a degree, and it is 1/360th of a degree. Sorry, I lied to you. I was thinking incorrectly. 1/60th of a degree. Meaning, what's happening there is we're breaking up that degree between 29 and 30. We're going to put 60 more units in between there. Right? We're going to break it down even further. Now, when we go to seconds, we take each one, like the minute, and we break it down into 60 in between. So this is actually 3,000 or 3,600th of a degree. So it's a way for us to be even more precise with our degrees. I had a student last semester that he used these with the people that stand out on the street. My brain just blanked, but it's like the measuring how steep a road is. There's a word for that person, but they use a title for that person. I guess is a better way to say that, but they actually use this. It breaks it down. Our degrees, sometimes if we're talking about a really big circle, in between could be, quite a bit of room. If we're talking about the revolution of something due to gravity and, something really big, those little bitty breakups may feel like a lot of space. Okay, so that's what a minute is. A minute is a 1/60th of a degree. A second is 1/60th of a minute, or 1/60th of or 1/3600th of a degree. So it like splits it down really little. Now, how this is written is like this. If we take a look down here at the bottom, this says 117 degrees, 15 minutes. That's that, forget what that thing's called, apostrophe maybe? And then 45, and then the double tick marks to represent seconds. So that's like 15 minutes is a fourth out of 60, right? 15 out of 60 is a fourth of a minute, of a degree, I mean. 15 minutes is 1/4 of a degree. And then we have 45 seconds. That's 3/4 of a minute, right? Just like time works. But that's how we break it down. We get a very accurate description based on just revolution rather than decimals. Okay, so what we care about here, though, because we're not going to use it a whole lot, it's going to pop up here and there. Some of you guys are going to have full careers where that's all you ever do is degrees, minutes, seconds. So we got to figure out how to convert in between the two. So the first thing we're going to do is we're going to take 42. Switch to the sticker pen, I like it better. 42.125 degrees. And how we work this out is we're going to say, hey, this is 42 degrees. And then this 0.2125, remember, that's a fractional part of a degree. So I could take that, and I'm going to say, hey, okay, 0.125, I'm going to times that by 60, because that's going to tell me 1.25 is the percentage of the degree, but I want it in 60 because I want it in minutes. So I just take that first one, the decimal, multiply it by that. If we do that, we get 42 degrees, and I get 7.5 minutes. Now, the problem here is, remember the whole point with the minutes, degrees, minutes, seconds, is we don't want the decimals, right? We can get it down to a very accurate number without the decimals. So what we do from here is we do 42 degrees, 7 minutes, and now this is 0.5 of a second. So I'm going to multiply that 0.5 because that's a fractional part of a minute. Now that's going to give me my seconds. So this is 42 degrees, 7 minutes, and 30 seconds. So that gives us a very accurate description of that angle without using a decimal to break it up. This has to do a lot with gears turning, right? That we can get an accurate, if I just turn a gear to move things, I can break them into 60s because that's how we typically break our full circulation up. Okay, now going the other way, I think this way is a lot easier. We're going to take 117 degrees, 15 minutes, and 45 seconds. Okay, we keep our 117, that doesn't change, and we're going to add this to 15 over 60, right? That's going to give me a fractional part of 15 minutes out of 60 minutes. That'll be a degree, right? And then I take 45, and this is kind of tricky, but 45 in the idea with degrees, there's going to be 3,600 of those. So it's 45 out of that. That'll give me a fractional part of a degree. If I plug all that into my calculator, I get 117.2625. So now I have a nice, pretty measurement in decimals for that same degrees, minutes, seconds. Okay, convert that DMS, or to DMS. I think I wrote this bad. Oof, these are bad notes. Convert that to DMS and radians. That's what they're wanting us to do. So we'll do the DMS part first. 27.38 degrees is 27 degrees. And then the fractional part of 60 minutes. All right, plug that in your calculator. You get 27 degrees, 22.8 minutes. All right, again, we don't want a decimal there. So I'm going to go 27 degrees, 22 minutes, and 0.8 fractional part of 60 seconds in that minute. Okay, that ends up being 27 degrees, 22 minutes, and 0.8 of 60 is 48 seconds. So we have converted. They also want us to convert to radians. Well, I'm not going to use the DMS one because that would make that very difficult. I know this is 27.38 degrees, and I know I want degrees to cancel, and 180 and pi are the same thing, so I'm going to put 180 degrees on the bottom and pi on the top because that would make the degrees cancel. All right, this is going to come up with out as a rough answer. Meaning I'm not even gonna round. I'm gonna write everything that's on the screen. That's typically what I do because rounding errors can cause a lot of issues. So I typically don't round anything unless they tell me to. And then during a problem, if I need to round in the middle of the problem, I don't. I don't round until the end of my problem. That way I don't make a rounding error. Rounding errors can cause a lot of issues, especially those of you guys that are going to be doing some kind of engineering. If you cut something too short, if I were to cut off millimeters of every measurement of a bridge, the bridge could collapse. Even though it felt like millimeters cutting off wouldn't be that big of a deal. But collected rounding errors can add up to quite a bit. For instance, say you had 100 people and everybody needed to save up enough money to make a big purchase. But let's say everybody paid $5 less than what they should have. And maybe this was like several $1,000s of something. Well, if several hundred people don't pay $5, in the end, even though $5 is small, the overall picture, we're going to be lacking a lot of money because several people are lacking $5. Same thing with rounding measurements. We don't want to round until the end because we don't know how big of if I chop that off, how big of a mistake that's going to probably make for my problem. So be very careful with rounding. I will make sure to communicate where to round on test, and then our online software does a great job telling us when to round.